Students, in the previous lecture, we have learned equation for acceleration. Acceleration is delta v divided by delta t, and we have also learned the direction of acceleration is depending upon the direction of change in velocity of the body. That is what we have already learned in previous session. Coming to the next session, we will be learning about equations of motion. In previous lecture, we have learned acceleration A is equal to delta V divided by delta T. This is final velocity minus initial velocity by final time minus initial time. Acceleration is equal to V minus U by T. And this can be rewritten as V bar is equal to U plus A into T, and these are vector quantities. This equation is the equation which gives you relation between final velocity, initial velocity. If you know acceleration, time taken and initial velocity, you can calculate final velocity of the body. And this equation is first equation of motion. And second equation of motion gives you relation between displacement, that is S is equal to ut plus half at square This is equation number 2. And the third equation is v square minus u square is equal to 2as. Of course, all these quantities can be vectors. You can use vector rules in order to find out these additions and subtractions of the terms. These obey vector rules. And there is another equation which gives you the relation to find out displacement traveled by the body after nth second. Displacement or distance covered by body in nth second. Displacement traveled by the body in nth second. Say for example, you have in 1 second body have traveled 5 meter. In next 1 second body have traveled 6 meter. And in next 1 second body can travel some another meter. Now total length traveled from here to here, it will be 11 meter, and this is in 2 seconds. Now in this particular nth second, so this 1 second you can write it as third. This is third second. In this particular third second, yes, third is equal to how much? So for this you can derive an equation which will be learnt in lower sections, which is written as distance traveled by the body in nth second is equal to u plus a into n minus 1 by 2. This is distance traveled or displacement traveled by the body in nth second, where u is initial velocity, a is acceleration, n is that particular second in which you are calculating the displacement. Using these equations, we can solve many numerical problems in kinematics, as these are kinematic terms. Kinematic terms are those like we have initial velocity, final velocity, displacement traveled, displacement traveled, time taken, acceleration A, all these quantities can be related. They can be related one with the other. Now, if you see those relations, they all are assumed to be as these equations which describe motion of the body. So therefore, these equations are called as kinematic equations or equations of motion. Now, in next coming slides, we will be solving few problems based on equations of motion. Students, in this particular problem, we have a body travels 200 centimeter. This is 200 centimeter and it is traveled in first 2 seconds. And in the next 4 seconds, body is traveling a distance of 220 centimeter with constant deceleration. So here body is traveling with the deceleration, and this total body, as starting from A to C, it is moving with some particular constant deceleration. Constant deceleration. Now you are supposed to find out velocity of the body at the end of 7th second. So here 2 second plus 4 second, totally it is 6. It will be traveling one more second and that become 7. Now you are supposed to find out velocity of the body at the end of 7th second. That means velocity at end of 7th second is equal to how much? You are supposed to find out velocity after 7th second. In order to find out that, we will be using basic equation v is equal to u plus a into, as you are finding velocity at 7th second, you can write it as 7 because t is equal to 7. So after 7 seconds, what is its velocity? You are supposed to find. Now let me take this as equation 1. Taking this first, as we cannot directly use equations of motion in this problem, because you do not know what is u, you do not know what is a. We will be dealing this as different parts. So first let me take this part. Now let initial velocity be u and final velocity at this position is say some v1 and distance traveled here is s1. Now this distance traveled s1 is equal to u into t. Time taken is 2 seconds plus half into acceleration into 2 square. And this distance s1 is equal to 200 centimeter. It is 200 into 10 power minus 2 is equal to 2u plus 2 square is this 2 gets cancelled. It is 2a. This is 2 zeros and this gets cancelled. So it will be 2 is equal to 2u plus 2a. 2 on both sides gets cancelled. So it is 1 is equal to u plus a. This is equation number 2. Let me take this as equation number 2. Now coming to next part, say this part. Now the total distance traveled in this part is 220 centimeter and the time taken is 4 seconds. But the common thing for these two parts is initial velocity is the same. Initial velocity in the first part AB and initial velocity for the total part A to C, that is same. It is u. Therefore, I will be now taking this total length travel, that is s1 plus s2. So total distance traveled is s1 plus s2 is equal to initial velocity is same u into time taken will be 2 seconds plus 4 seconds, that is 6 seconds plus half acceleration is a into t square, that is 6 square. S1 plus S2, it is 220 plus 200, 420. 420 into 10 power minus 2, because centimeter I am converting into meter. 6u plus 6 square is 36. 36 by 2 into A. It is 2 ones 2, 2 eights. It is 6u plus 2 ones 2 and remainder is 1, 2 eights, 16. This is 18A. And here it is 4.2 is equal to 6u plus 18A. This is equation number 3. Now you should solve equation 2 and equation 3. Solving these equations. So it is 1 is equal to u plus a. Multiplying this with 6, it is 6u plus 6a, and you can subtract them. It is minus, and this becomes minus, and this becomes minus. So finally it is 4.2 minus 6. This is equal to minus 1.8 is equal to 6u gets cancelled. 18 minus 6, it is 12a. 18 minus 6, it will be 12a. And this gives you acceleration as a is equal to minus of 1.8 divided by 12, and it is in meter per second square. So it is a is equal to minus of 18 by 12 into 10 power minus 1. This gives you 3 4s 12, 3 6 18, 2 2s and 2 3s. This will be a is equal to minus 3 by 2 into 10 power minus 1 meter per second square. Acceleration, we have got it here. Take this acceleration, substitute in equation 2. That gives you 1 is equal to u minus 0.3 divided by 2. This is 2 is equal to 2u minus 0.3. 2 plus 0.3, it is 2.3 is equal to 2u. U is equal to 2.3 divided by 2. That is 2 ones 2, 0.2 ones 2. Remainder is 1025. U is 1.15 meter per second. This is u value. Now take this u and a, substitute in equation 1. So final velocity you can write it as v is equal to u is 1.15 plus acceleration, as it is negative, I am writing it as minus of 0.3 into 7. This gives you the final expression, that is equation for velocity. Now it is 7 3 is 21, it is 2.1 divided by 2. It is v equal to 1.15 minus 2.1 divided by 2. This gives you 2 ones 0.0, 0, 2 5s 10. This is 1.15 minus 1.05. Final velocity will be equal to, it is 0 and 1, 0.10 meter per second. This is the final expression, final value for velocity after 7 seconds. Coming to the next problem. In this problem, here we have a bullet moving with 20 meter per second. That means initial velocity of the bullet is equal to 20 meter per second. It strikes a wooden plank and penetrates 4 centimeter. Distance traveled in the plank is 4 centimeter. I should convert this into meter. That gives you 4 into 10 power minus 2 meter. All units should be in the same system of units. Find time taken to stop. You are supposed to calculate time taken. Now clearly, here is a wooden plank, and in this wooden plank, bullet is traveling a distance of 4 centimeter, and finally it comes to rest. That means v is equal to 0. Initial velocity, it is mentioned as 20 meter per second. Distance is known to you, v and u values are known to you. From here you should find out time taken. In order to find out time taken, s is known to you. You can use this equation. S is equal to ut plus half at square. Take this as equation number 1. But as you do not know acceleration, first we should find out accelerations and substitute in equation 1 so that you will be getting time taken. Or even we can use v is equal to u plus a t. Either you can use this equation. Equation 2 also is suitable in order to find out time taken. Now this, in order to find out a, I will use v square minus u square is equal to 2as. 0 minus 20 into 20 is equal to 2 into a into s is 4 centimeter, 4 into 10 power minus 2. Now here it is 4 5s 20 and 2 10s 20, 5 10s 50 minus 50 divided by 10 power minus 2 is equal to a. This gives you acceleration as minus 50 into 10 power 2 meter per second square. That is acceleration. Take this acceleration and use it in equation 2. Final velocity is 0. This is equal to initial velocity is 20 meter per second plus acceleration is minus 50 into 10 power 2 into time taken. You should calculate. This is 20 divided by 50 into 10 power 2 is equal to t. Now 0 0 gets cancelled. The time taken t will be equal to 0.0. It is a 5 fourths 0.4. T is equal to 0.4. T is equal to 0.4 into 10 power minus 2 second. This is the final value for time taken. Students, in last two problems we have used the equations of motion and we have solved different unknown quantities in those problems. Now we have another problem where velocity of the body moving with uniform acceleration of 3 meter per second square. First write down the quantity what is given to you. Acceleration is uniform, it is 3 meter per second square. And velocity of the body is changed through 30 meter per second in certain time. That means velocity is undergoing change and this is 30 meter per second. In how much time it is not mentioned. Let time be t second. Time taken be t second. Now average velocity of the body during this time is 30 meter per second. So V average is equal to 30 meter per second during this time. Now find the distance covered by it during this particular time. You should find out what is the total distance covered in this particular time. Now as we know, V average is equal to total distance traveled divided by time taken. This is equal to 30 meter per second. Let this be equation 1. In order to find out S, you need to find out this T. So for T, we have basic equation acceleration A is equal to delta V divided by time taken. This is acceleration is 3 meter per second square, which is equal to delta V 30 divided by T. Now finally, you can calculate T as 10 second. So time taken will be 10 second. Take this time taken and substitute in equation 1. Distance travel divided by 10 second is equal to 30 meter per second. Second and second gets cancelled. Distance travel will be equal to 30 into 10, which is equal to 300 meter. So distance travel with this average velocity is equal to 300 meter. Now coming to the next problem, a particle, actually this let us consider as alpha. An alpha particle travels inside a straight hollow tube 2 meter long. That means how much length it is. This is 2 meter. 2 meter long of a particle accelerator under uniform acceleration. Acceleration is uniform, it is mentioned. How long is the particle in the tube if it enter at a speed of 1000 meter per second? That means when it is entering into the particle accelerator, its speed is 1000 meter per second, and it is leaving with velocity 9000 meter per second. So let me take, this is a particle accelerator, and when the particle is entering here, it has velocity 1000 meter per second, and when it is coming out, it has 9000 meter per second. What is the acceleration during this interval? And distance length is also mentioned, it is 2 meter. You should now find out acceleration. For finding out acceleration, we have basic relation. A is equal to v square minus u square divided by 2s. V is known to you. V is final velocity. It is 9 square. It is 81 into 10 power 6 minus u is 1 into 10 power 6 divided by 2 into s is 2 meter. This is equal to 81 minus 1. 80 divided by 4 into 10 power 6 meter per second square. That is acceleration. Just v square. V square is 9000 whole square. U square is 1000 whole square. That gives you 80 by 4 into 10 power 6 meter per second square. And now how long is the particle in the tube if it enter? Now you are supposed to tell how long. How long mean you should calculate time taken. Now finding this time taken, you can use relation v is equal to u plus 80. Final velocity v is equal to 9000 minus initial velocity is 1000 divided by acceleration is 80 into 10 power 6 divided by 4, which is equal to t. 9000 minus 1000, that is 8000. 8000 divided by 8 is 80 into 4 into 10 power 6 is equal to t. Now this 0 gets cancelled, and two zeros here goes. This is remained 4, and this is 8 and 8 gets cancelled. What is left over here? 4 divided by 10 power 4 is equal to t. Therefore time taken is equal to 4 into 10 power minus 4 second. During this time, the particle is being accelerated to 9000 meter per second.